My name is Ryan Miller. This is my energy conservation project, and what I'm wondering is if I crank the heat in my apartment, is it going to send my landlord to the poorhouse? Well, the main question here is, when I get home from work, which is roughly 6 o'clock, I'll be up for maybe 4 or 5 hours. I want to turn the heat up from 60 all the way up to 70. And I'm wondering how much extra this is going to cost my landlord per month. Why? Well, because my landlord gives me a base rate for rent, which heat is included. So when I crank it up, the heating bill doesn't come out of my pocket, it comes out of his pocket. And I'm wondering if I want to live here for more than just this year, or for the rest of the winter, do I need to keep it at 60, or can I afford to crank it to 70? How am I going to do this? Well, I'm going to pay attention to the operation of the furnace. I'm going to see or observe when it turns on and how frequently it turns on. Assumptions, of course, the colder it is outside, the more frequently the furnace will turn on, and the longer the furnace will stay on. And the outside temperature might fluctuate, making data less accurate. Well, both these assumptions were correct, well, partially correct. The furnace usually only turned on for 10 minutes at a time, no matter how cold it was, but it turned on more frequently the colder it was outside. How did I collect the data? Using a clock. When the furnace turns on, I record that time. When it turns off, I record that time. Then when it turns back on, I record that time. So I know how long the furnace has been on, and I know how frequently the furnace turns on. I'll also record the inside and outside temperature, the temperature that I set the thermostat, and the thermostat works in a way where if I set it at, for instance, 70, it'll heat the apartment till about 73, then turn off, and then when the thermostat gets, or when the temperature of the room gets back down to 70, it'll click back on, heat it to 73. So I recorded both those just for, I didn't need to, I later realized, but I noticed that the computer, or sorry, I'm jumping ahead of myself here. The computer, the refrigerator, the lights, my own body heat, these are all things that put heat into the room. So these are all to my benefit, of course. This is the data that I collected. I'm showing you this, but you probably can't see it anyways, but I just wanted to show you how much data I collected. I probably should have collected maybe 4 times this amount to get truly more accurate data. This is a zoom in of the data I collected. Here's the columns: outside temp, furnace turns on, furnace turns off, furnace time on, and time between furnace, or the intervals of when the furnace turns on and off. This is all the important stuff that I took. Unrecorded variables, there were a couple. I wish I would have paid a little closer attention to the me cooking and me opening the door to the outside, that sort of thing. You know, I think they played a part in some of my data. Interesting note, when the outside temperature was 40 degrees and I had the thermostat at 60, I noticed that the furnace just never turned on. What this tells me is all the things inside the room, me, my computer, my fridge, my stove, all those things generate 20 degrees extra heat. So that's kind of nice. This was the equation I used. Probably can't see it, but my furnace spews 0.6 gallons of fuel per hour, and knowing that, I was able to use my conversion, 1 hour equals 60 minutes. I was able to calculate using this ratio of 0.6 over 60 fuel consumed in gallons by plugging in the time the furnace was on in minutes. This is plots of data. Getting a little distracted. Alright, so as you notice here, The curve, this is, hold on. Let me just start by saying all this data was taken with the outside temperature of 40 degrees, and the blue line represents when the thermostat was set at 66, the green line when the thermostat was set at 70, and the red line when the thermostat was set at 68 degrees. Now, one thing that should be obvious, maybe if you studied it long enough, sometimes it's looking at curves like this, a little confusing. Notice that when the thermostat was set at 66 degrees, the slope of this line is just as steep as when it was set at 70. I think what was going on here this day, when I had the thermostat set at 66, I think I was cleaning my apartment and I opened the outside door a couple times, taking the trash out, and I think the furnace kicked on a couple times extra because of it. So, anyways, some more data. Notice the slope of the lines indicates how much extra or how much more diesel is consumed over time. Finding fuel consumption. Well, what I had to do is I had to find the slope of each line to determine the slopes of these lines will give me the gas consumed per hour. So I used my slope formula here, calculated the slope. Using the slope, I was able to determine gas consumed per month. And with this, I was able to calculate that if I heat my apartment 70 degrees for 4 hours a day, I will in fact use 4.1 more gallons of fuel per month. Here is a chart of Southeast Alaska average yearly temperature. Reds indicate high, blues indicate low. Basically what I'm going to do here is I'm going to calculate how much fuel my landlord uses or I use over the winter, or how much it's costing my landlord, how much fuel I'm using, how much it's going to cost my landlord. So after I did some calculations, I noticed that I used 24.5 more gallons of fuel over the entire winter to heat my apartment 70 degrees for 4 hours a day. That's a cost of $100 extra per winter. Blah, blah, blah. Basically that last chart helped me calculate this data here, which what I'm doing is I want to compare let's just say that on average temperature is 30 degrees during the winter. I want to calculate how much it's going to cost me to keep my thermostat at 60 degrees the entire time, which I did, $228 a month. But what if I wanted to increase for 4 hours a day the temperature to 70 degrees? That is going to be $244 a month. A difference of $15 a month so that I can live a little more comfortably in the evenings. Conclusions? Well, 15 bucks a month. When you're talking 200 and some odd dollars for a heating bill, that's a small percentage, at least in my opinion. My landlord might not agree. Also, if I took more data, the results would probably be more accurate. In the future, what can we do? Well, we could definitely take more data and get the results much more accurate. We can also change the nozzle in the furnace and see what, if we were putting more gas into the system, heating the room up quicker, would that change fuel consumption? Probably would. Who knows? Next, there's my reference. Thanks for listening.